All right, class. So here we go with the solving radical equations. I will say that these are pretty heavy. Um, so along the way, I'll give you guys some tips and some quick reviews on some properties that happen when you're dealing with square roots. So as we said in class, when you're dealing with radicals, I was telling you guys to isolate the radical. In this case, you have 2 on this side. So you're welcome to start by isolating either. I'm gonna pick one in this video. So you have your problem here, and you want to isolate one of the radicals. You're welcome to choose which radical you're gonna isolate. I'm gonna decide to isolate this radical. So therefore, we need to get this radical out of the way. So I'm going to subtract it to both sides. So it's going to get canceled off. And then on the right side, these are not like terms, right? So we're going to have, I'm just going to rewrite it horizontally. So 3 minus the radical that I'm subtracting. Okay? So now we got this radical all isolated. So to get rid of the square root, we need to raise both sides to the power of 2, or to the second power. So we go ahead and we do that. Remember that when you raise the second power and the square root, it'll cancel off. But here you have a subtraction, so you have 2 of these. 2 terms on the side of 3 and the radical expression that are subtracting. So it helps to rewrite it so that I see that I'm multiplying it with itself versus just squaring 3 and squaring the square root here. Okay, so to do this, it's just like you would do with let's say 3 minus x. It's just that you have 3 minus this radical expression, so you would still have to distribute on both sides, or as you guys say, FOIL. But before we do that, let me give you a quick review on radicals. So if you have this radical expression where a is outside the radical and b is inside the radical, and you multiply it with another radical expression where c is outside and d is inside, then what happens is the outside values end up multiplying and they stay outside, and the inside values end up multiplying inside the square root. And then so you kind of multiply them in, and then your product is just going to stay inside the radical. So we're going to do the same thing here. Now what I want you guys to notice is that here we just have like a minus square root. Think of when you guys are doing minus x, you can rewrite it as minus 1x. So I'm going to do that here on purpose so that I see what's outside my radical, what kind of number, kind of like my a here that's outside my radical symbol. So let's go ahead and we're going to distribute the 3 with this 3 and the 3 with this radical expression. The 3 times 3 is the 9, and then the 3 it's not inside a radical, so it's going to multiply with the -1 here, which is why I got a -3. And since this does not have a radical at all, this just comes along with it, and there's nothing to multiply with it, so it just stays the same. Then I go ahead and I distribute the second expression. Again, the number outside, the -1, is going to multiply with the 3. That's where we got -3 here. And then we're going to multiply this one with this expression. So this is going to be the -1 times the -1 becomes a +1. And this expression inside the radical is like my b. And this expression inside this radical is like my d. So when they multiply together, that's why I wrote a square here, because they're multiplying each other and they're the same thing. So I'm running out of room, and it's going to happen a lot in this problem. So I'm just going to rewrite it here. Now, think of this as kind of like 9 minus 3x and then minus 3x. You would combine the -3 with the -3 to give you a -6x. So the same thing happens with radical expressions. You're going to combine the values outside the radical, and you're just going to add them up, so we get a -6. And now we got to deal with this square and the square root. So they cancel each other off. So we just end up with whatever was inside the radical, which is the negative x plus 5. Now the only thing that has a radical is this expression. The 9 does not, and this does not. So we can see we can combine these together. The 9 and the 5 will combine together. And then when I add them up, I'm going to get 14. So we're going to get this negative 6 times the square root expression. And then our minus x here. This is plus the negative, so it just becomes minus. And a plus with a plus, that's just going to stay positive. So it's going to be 9 plus 5, which gives me my plus 14. All right? If you want, you could pause it and then just kind of figure out and, slowly absorb what just happened in this past few steps. All right. So now we have another radical. So now we got to isolate that radical right here. So to do that, let's go for it. So to do that, we're going to add the x and subtract the 14 off to this side. So then we get 4x, and then we're going to get negative 10. Now, normally in class, you would, you want to divide this negative 6 off. And when you do that, what's going to happen for this problem is that you're going to end up with fractions here, because you're going to divide this by negative 6, and you're going to divide this by negative 6. So you're going to end up with negative 4/6. And again, when you have a fraction, if the negative's in the bottom, it could also be moved to the top, or it could be placed in front of the fraction, okay? Those are all equal to each other. And then here, the negative with the negative, two negatives dividing makes it a positive. But then multiplying this looks like a nightmare. So instead, what you could also do is you could just have not divided the negative 6, and you could have squared it from here, okay? Because this is all just multiplying together. So when you squared it, you're going to do negative 6 times negative 6, which gives me positive 36. And when you square the radical, again, the square root symbol disappears because they cancel each other off, okay? So this square is squaring the negative 6, which became positive 36, and it's squaring the radical expression, and then the square root and the square cancel off, which is why it's gone here. Here, this square, I'm multiplying the expression with itself, so I go ahead and I FOIL that. So we got negative 16 x squared minus 40x plus 100, combine like terms. So I combined here the negative 40x with the negative 40x, and then here I distributed the negative 36 inside here. All right, we have a quadratic equation, so we're going to have to move everything to one side and set it equal to 0. So here we go. Do that. And finally, we get a quadratic that looks like more familiar territory. So now let's try to let's go to another page and figure out how we're going to solve that one. All right, so notice that this is 16, it's divisible by 4, 44 is divisible by 4, and 80 is divisible by 4. So I'm going to take out a 4. So now what we got to do is we got to factor this quadratic inside of here. I'm going to do it through the AC method. So 4 times negative 20 is negative 80, and I need to add to negative 11. So I try a bunch of different pairs. You can try 2 and 40. You can try 80, I guess, and 1, but somehow you need to get negative 11. I also noticed that this ends with a 0, so I know it's divisible by 5. So then I checked, and then 5 times negative 16 works, and it adds up to negative 11. So I went ahead, and then I continued with that, and I split up the negative 11x into minus 16x plus 5. Then I did some grouping, and I finally was able to factor it. So here we go. So that this factors into x minus 4 and 4x plus 5 equal to 0. So we want to find the zeros here. So we get x equals 4, and then we set this equal to 0, and we get negative 5/4. And like I said, I told you guys these problems take a very long time, and you're going to get very excited and want to say, okay, these are my answers. And then Newton's going to say, nope. And unfortunately for this, we have to check our work. We have to check that both these might work, or only one might work, or none. And if none work, then you would put no solutions and then throw your computer at the wall. Just kidding. All right, so let's check here. So we need to check that when we plug in our x values here, all of this is going to simplify to the number 3. Okay, so let's check for x equals 4. So I plugged in the 4 here, and I got negative 4x. Plugged in the 4 here, and I got 3 times 4. And this side, we're going to get 1. On this side, we're going to get 12 plus 4, which is 16. The square root of 16 is 4. Unfortunately, it's 5. So it's not one of the solutions. So we cannot include it as one of the solutions for the radical equation, even though it was a solution for the quadratic equation. So then we check the other nasty fraction that you're probably like totally not wanting to check, but we must check. So we plug it in. I plug in the negative 5/4 here, and I plug in the negative 5/4 here. The negative and the negative will cancel off to give me a positive 5/4, and the 3 multiplies with the negative 5. Think of this as 3 over 1, and then the 1 multiplies with the 4, so we get negative 15ths over 4. And I write these whole numbers over 1 because I'm going to end up having to add fractions. I need a common denominator when I add fractions, which is going to be 4 for both of them. So I multiply top and bottom by 4. So then we get, this becomes 20/4, and this becomes 16/4. So we end up with 25/4 plus, and then negative 15 plus 16 is 1. So we get 1/4. The good thing is that all these turned out to be perfect squares, so I made this a lot nicer than I was thinking it was, going to be. Another property of radicals is that when you have the square root of a fraction, you can just take the square root of the numerator and take the square root of the denominator. So that's what I did here. These are all perfect squares. So we get the square root of 25 is 5, the square root of 1 is 1, and the square root of 4 is 2. These are common denominators, so I can add the numerators to give me 6 over 2, which equals 3. So it is one of our solutions. Yay! Alright, guys. I will not put something like this on the exam, okay? It's just the homework. You guys have an entire week to do it. So, that's why these problems are a little longer. But you might expect a radical equation with just one radical expression, but don't expect something with 2. Also for me, that'd be pretty intense to grade.